Alright, so what you just saw there was the initial stages of the sequence. Basically, let's see here, there's a photoresistor. Is basically looking at the flash of lights to see, to determine a random number. The random number then chooses a particular sequence, 1 through 4, which is set up for case selection. Now, on those, as you can see, here we go, it cycles through, each case cycles through 5 times at a random number, basically from 1500 milliseconds to 11,500 milliseconds. Completely randomized, completely generated, randomized. And that will determine how long. Future setups, this will actually be a stepper motor hooked up to a target. And yes, that is all the time you get. So it'll stay down for a selected number of milliseconds. It'll go up for a second and a half and come back down. Again, this is testing phase. It'll actually be a 3-second pause between firing and so forth. Now it's down for 8,297 milliseconds, comes back up, comes back down, and it's down for 6,966 milliseconds. That's 6.9 seconds. And it comes back up, and it comes back down for 3,282 milliseconds. Comes back up, comes back down. It's all, you can tell, it's running in the first case scenario. And the whole system resets and starts again. Let's see here. And it gives an example of all of the code put into this just to get this thing going. Apparently, with microcontrollers, random is not random, so you have to make it think that it's random. In fact, it's not. Yep, still going, still going. There we go. Right here is our reset, testing new parameters, version 3. Tell you the case selection 2. As you can see, the last case selection was 3. Now it's generating 1.5 or 1.692 milliseconds. Seconds, pardon me. 1.84 seconds. 10.151 seconds. And target raised, target down. Seconds until target rise. 6.6 seconds. Yep. There's our reset. Case selection 1. So first one was case selection 3. Randomly chose case selection 2. Randomly chose case selection 1. It's all set up on randomization. So even the numbers that are selected within each case selection, which is basically a switch case of just 4 different choices. The choices are chosen at random, well, supposedly at random, and then the seconds upon until the target will rise again is also randomized. How the number for randomization is determined. So for random seed, you can throw a couple of just random numbers in there. However, I figured out that random is random does, basically. The best way to determine, the random of it was to have a photoresistor basically mapped out a low and a high range, low to high range based on whatever set of seconds. So like this is LED A, B, C, D. These are set at 500 milliseconds, 1000 milliseconds, 1.5 milliseconds, and then 2000 milliseconds. And as you can tell, the photo resistor is at an angle, and so every couple of case selections on the program is actually going to light up one, two, or all three of the series of LEDs at particular times. So this one might light up, the next one these two, the next one these two. It seems random, but it's not. However, that's going to throw a different value for brightness for your photo transistor. Now that brightness is actually comes down to a specific number that was mapped out. That specific number is basically the random number generator to basically choose not only the case selection that it's choosing, but also to have to choose, you know, the seconds and so forth. If you look up here, you got I just went up here. Let me get back to it. Oops. Where are we? So if we look here, here's case selection 1, case selection 1, but you know, was it 9299 starts out, and this one is 9070. The next one down, also case selection 1, starts out at 3836. So as you can tell, completely random, and that is basically all based off of the numbers that this is generating from the, you know, completely unrandomized sequence of these 4 LEDs that are coming from there. So yeah, random is as random does.